Have you ever been at a loud event and people misunderstand what you're trying to say? Like you're trying to say one thing and people hear something else. It's a problem that can happen to the best of us. I'm pretty sure Taylor Swift didn't intend on singing about Starbucks lovers, but millions of her fans misheard her sing those lyrics in her last album, and they thought she was getting corporate sponsorship. In a noisy environment, it can be really difficult to get your message across. And this isn't just a problem for humans and megastars. Trying to stream your favourite song or even make a phone call means you've got digital messages flying around that are getting affected by noise and static. And it's a big problem because while you talking to your friend can be easily fixed, what if it's zeros and ones that's getting mangled? How's your phone supposed to work out what the song's actually supposed to be? And it's not just a problem for downloads and phone calls. New Horizons spacecraft zoom past Pluto, taking photos of this distant world for the very first time in human history. Now, what would have happened if that message didn't come through? What if the zeros and ones that make up this photo bounced off a rock between Saturn and Jupiter, or maybe even was blocked by a bird flying in front of a satellite dish here on Earth? That would have actually caused these holiday snaps not to come through, which would have been a big problem, because let me tell you something, that's a very expensive drop call. So the way to solve this problem, not just for New Horizons, but just for you on your phone, is using some very clever maths. And they're called error correcting codes. Now, I know that might sound a little bit hardcore, maybe even a little bit nerdcore, but we've actually got an activity for you to do just to see how it works. So first of all, we need to simplify the situation. We're not trying to send the data of a photo or even a phone call. All we're trying to do is send a code. So here we're just talking about numbers. Now we're going to simplify the situation even further. Rather than having 10 digits to choose from, we're actually only going to give you 4. 1, 2, 3, 4. And the code itself is only 4 digits. So you could do 3, 2, 1, 4. So here's your code, right? But this actually gets sent off. It's flying through the air. And what happens? Well, just like in real life, there's static. You might lose 1 in 4 of your code. So as it gets sent off to some central place to get verified, it's not actually getting 3214, it's getting 324. And if you know that you'll always lose 1 in 4, then this might not happen every time. You try and send it through again, and instead you get 321, or maybe even 314, or maybe even 214. But in any situation, you're actually not going to get the complete message. Now, this happens all the time, no matter how careful you are. When you send information out, you're going to lose some of it. So one way around it is that you actually get cut some slack. If you've got a 4-digit code, perhaps you get to send it 4 times in a row. Because that way, even if it's still you're losing 1 in 4, perhaps it's random enough that you can still work out a way to get out the original code. Because this is the sort of thing you can tell a computer how to do. So now you say, yes, even though the message has got things missing, you say to the computer, well, look, just start from the top and write down the numbers you can find. So yes, the first number is 3, that's the first number of the code. The second number is 2, that's the second number of the code. The third number is, okay, we'll just hold your horses there. The fourth number is 4, yes, that's cool. But then you get a second shot. The first number is 3, I know that. The second number is 2, I know that. The third number is 1, I didn't know that. And now I have the complete code. And so by sending extra digits, you've got extra data that can actually deal with the static, and you can send your message through. But the problem is it has to work in every single situation, because I could send my 4-digit code 4 times, but what happens if I get static all in one line? What happens then? Well, if I say, yeah, look in the first part and you get the 3. Yes, look in the second part, you get the 2. Yes, look in the third part, no, look in the fourth part, you get the 4. Because what happens down the middle? Well, I never actually get that 3rd digit. So it fails. But maybe there's another way I could send the data to alleviate the situation. So what if instead I actually send the digits individually 4 times each? So if it's 3, 2, 1, 4, I actually send 3 4 times, and then 2 4 times, and then 1 4 times, and then 4 4 times. What would happen then? Well, if I lose the information that way there, like I did before, it still works. I go, yep, look there, that's the 3. Now actually look 4 numbers across, and you'll get the second number, yeah? Look 4 numbers across, you get the third number, yeah? And then look 4 numbers across, even if you get the static, it's all right, just move over to the next one, and that's what it will be. So this is a different way to get the actual code, but it works in this situation. It actually works even if you have it all in a row, because it still works there. Yes, 3, now look over 4, there's the 2, yeah, look over 4, there's the 1, look over 4, there's the 4. And so that's actually worked. What happens if instead you get 4 errors all in a row? I mean, that's pretty bad luck. But this happens. This is called a burst error. It's where you get a sustained drop. And this is pretty bad, because here, sure, you get the 3, 2, and 4, but again, you're just missing out on that third number. You just won't know what it is. And the reason why is because, well, if it's 3, 2, space 4, it could be anything. It could be 3, 2, 1, 4, or it actually could be a repeated digit. You just don't know. But there is a way that you can actually send your information. And it's pretty simple. And it's this: a Sudoku. Now, this Sudoku is your 9 by 9 Sudoku. This is the way it looks, but in actual fact, when you fill it out, they actually look like this. So imagine now we actually send a Sudoku. So if I send this information and we start losing information with static, well, that's fine, because in a way, it's like, well, you're sending a Sudoku with the static. It's just like sending a Sudoku with holes. But anyone who's good at Sudoku, and computers are very good at doing Sudoku, they can work out what's actually missing. And so they'll get the whole message. Now, how can we use this for our 4-digit code? Well, what we do is we need to simplify the situation. We don't want to use a 9 by 9. We actually use a 4 by 4. Now, this is actually simpler than your regular Sudoku, because it only uses 4 numbers. But the rules are the same. So the numbers 1, 2, 3, and 4 are placed once in every row, just like would happen in a 9 by 9, once in every column, and then once in every 2 by 2 block in this case. And so what happens? Well, we take 3, 2, 4, 4. This is the code we want to send, but we actually put it in our Sudoku. But we put it in special positions. And what I'm going to do is I'm actually going to shade up the special positions here so we can actually see where they've got to go. Because we've got to put the first digit in the top left corner, the second one in the bottom right of that one, the fourth one we're going to put in the top right of that one there, and then we put this one in the bottom right. And so now what we have is an incomplete Sudoku. But what's really interesting is that the 3 there, well, the 3 appears once in every row. See, once in that row. The 2 appears once in that row. The 4 appears once in that row. The 4 appears. The 3 appears once in that column. 4 and once in that column. 2 once in that column. 4 and once. And the 3 appears once in that square. The 2 appears once there. The 4 appears once there. And the 4 appears once there. So they're actually separated. But what's great is that we can now complete this Sudoku. So it's just like following the rules of a regular Sudoku. So let's start over here. So now what we want to do is we can't put a 2 here, and a 2's got to go in that box, so the 2's got to go here. Now we can't put a 3 here, and we've got to put a 3 in this box, so that means the 3's got to go there. The 3 can't go here, so we've got to put a 3 in that box, the 3 goes there. And the 4 here, well, we can't do that, so what we've got to do is look at the 2, and the 2's got to go in there. So now we keep completing it. So what do we see? So we can see that we've got to put the 4 there because there's a 4 here. Let's try putting the 1 there. So that's 1, 2, 3, 4. Let's put the 4 there. Let's put the 1, 2, 3, 4 in there. Let's put the 2 here because there's a 2 there, 1 there. And so we can actually see we've completed the Sudoku uniquely. So now what? Well, now we can actually send this information like so. But what's great is that it doesn't matter which 4 digits get static, because we could get static here, here, or here, or we could get static all in a line, or we can get static as a burst error. It doesn't matter which way we do it, because they all correspond to Sudokus that can just be filled. And once you fill them out, you end up with a completed Sudoku. And you look in the special spots that we said before, the first, the second, the third, the fourth, and you get the code. And if the code is right, which it will be, you have access. Sudoku, not just fun and games. It's actually serious.